This regarding is in regards for ruminants and perhaps the current hot situation these past few weeks. There are different ways animals can, say, reflect heat, and it may have to do with color and also absorption of heat. So we would expect those cattle with a lighter colored hair coat to be able to reflect more of the heat than, say, cattle with a darker hair coat. There are other things coming into play here, though. That also has to do with smoothness of hair coat. So an animal that has black color but has a smooth summer hair coat is much better able to withstand some of the heat than, say, an animal that had a winter hair coat. Similarly, the surface that the animals are on can affect them. That top picture, the black soil, actually that can be quite warm out there. Whereas where the young ladies are on the grass, somewhat less absorption. And having to do with forages like this, if you have to be doing a rotational grazing system, you might consider moving through those paddocks more rapidly so you can have more grass when they leave. That helps keep the soil temperatures lower. That bottom picture with concrete, kind of similar to that black dirt on top, can get very, very warm. So if you've got cattle on concrete, make sure that they can get off of it at times or somehow maybe get in the shade to escape some of the heat stress that could. Insulation's coming into play in the body. There's tissue, external hair, and then air insulation. Right now, the tissue, I'd expect there's quite a bit of vasodilation occurring, or a lot of the blood from the animal is close to the skin or moving out there so it can remove heat from the body core, whereas vasoconstriction, more of a function in cold weather. Also, the external hair, feathers, fur, highly variable. You think about a winter hair coat being thick, it sticks out from the body, but here in the summertime, it's smooth and shiny. And air movement over this hair, but also air between the hair follicles has an impact as well. Well, the sweat drifting off your hat or elbows doesn't help much. It's the evaporation of sweat that cools you down. Different animals are able to do different levels of evaporation. Chickens don't sweat, but they can pant. Cattle can sweat and pant. We'll talk about how well they do at these things. Sheep, similar to cattle. Horses can sweat more. They don't pant as much. Pigs are in a rough situation in a heat stress environment because they don't have sweat glands and they don't pant very much. So those are some numbers on sweat glands per centimeter squared and how many they are and how much sweat they can create. But in general, I'm looking at this lower part of the slide, usually good sweaters are poor panters. As panting increases, sweating typically can decrease. Pigs are lousy at panting and well, good panters are like dogs and chickens. The dogs, if you've seen them, a short, rapid response. Chickens are the same way. They flutter. So they don't take the air deep down into their lungs. So they're very efficient at panting. Whereas cattle, if you see cattle panting, they're in heat stress and may need to respond in kind. They're taking the air deeper into their lungs and then expelling it, but that takes more energy than, say, the flutter or a dog type of pant. Also, if cattle aren't laying down, that could be an indication that they're in heat stress. So they're trying to keep heat coming away from the body. Animal and humans alike live in a thermoneutral zone. There's that middle part of temperatures where the body doesn't have to work very hard. On the left-hand side is cold weather, and on the right-hand side, what we're focusing on is hot weather. So in hot weather, the body has to work harder. The sweating, panting, other things like that increases heat production, and they have to find ways to get rid of it. One of the ways they do that is reduce how much they're eating. So in hot weather, you can expect these animals to eat less. Different animals have different thermoneutral zones. For cattle, They don't start feeling hot until we're, in those mid to high 60s. Then they have to think of ways to uh, remove heat. And there you see pigs, very narrow, lower critical temperature compared to, say, cattle or piglets and chicks, that sort of thing. So, feed intake. If we have hot weather but cool nights, intake will go down some, but in hot weather with hot nights, feed intake will go down even more drastic. But let's look at the forage and temperatures and their impact, how plants are responding to. Well, although the lower bar shows centigrade, we can see temperate grasses increase in cell wall content more rapidly than in regular, say, more normal temperatures. So the grasses mature earlier in heat stress situations. Correspondingly, as you increase cell wall content, cell wall's not real digestible, you reduce the overall digestibility of the forage. DDM is digestible dry matter, and we see a reduction in digestibility, correspondingly a reduction in digestibility of cell wall. Also, light intensity has an impact along with temperature. High light intensity increases the content of water-soluble carbohydrates. Actually, that's a good thing. Whereas high temperatures decrease water-soluble carbohydrates. So there can be conflict at the same time between light intensity and temperature. So when there's a heavy cloud cover, you can expect some increase in cell wall content. But once again, light and temperature interact with each other. You might consider, if you have very mature forage and say the cattle look thin, consider some protein supplementation. That can increase the number of rumen bacteria working in the rumen and therefore counteract some of that reduction in digestibility. If you do supplement, try not to interrupt their grazing patterns. Now, typically, cattle will graze early in the morning and then in the evenings. Those are not necessarily the best time to supplement those animals because we don't want to interrupt that grazing behavior. Certainly, I recommend forage analysis, and this is probably the least scientific part. But when I go out to look at cattle, certainly I look at body condition. Are they fat or are they thin? But something else I can look at from time to time is their cow pies. If the cow pies look like the consistency of pancake batter, that indicates that actually the forage they're getting could be pretty good. Whereas low quality forage, if it stacks up in layers, and I use the statement wedding cake here, but if it's kind of tall, that's an indication that they're consuming lower quality. By all means, remember water. In heat stress environments, these animals will require more.